Okay, let's get started. So thank you everyone for joining the EnergyLab showcase, and thank you very much for coming along to the Transitioning the Grid deep dive session. We've got some really fascinating topics to talk about today. Transitioning the grid is a really interesting area. We're talking about incredibly large storage options. We're talking about unmanned drones, always an exciting topic, and we're talking about predictive and preventative maintenance to keep assets going longer and longer. So a really exciting session for everyone today. So welcome. I'll introduce everyone and then we'll get started with how today's going to run. So first, I would like to introduce Terry Woodcroft, who's the COO and co-founder from Aurtra. And with the Aurtra HealthSense product, it assesses, it analyses, and it acts to maximise the life of transformers on the grid. So welcome, Terry. Next, we've got Chris Cox, who's the Managing Director and co-founder from Infravision. They offer unmanned aircraft systems for power line construction. And last but not least, we've got Alex Post, the CTO and co-founder from MGA Thermal, who have created clean, economical and scalable thermal energy storage with a very novel material. And I think he's got a sample to show us later, so just hold tight everyone, to convert retiring thermal power stations into grid scale renewable energy storage systems. So a really fascinating area here. We're getting ready to kick off the pitches from each of the scale-ups, and then we'll have lots of time for open discussion and question and answers from each of the great representatives we have from the scale-ups today. So I've got some questions prepared to kick off, but you can definitely ask any questions that you want in the chat box. I'll be keeping an eye out on it during the time. If you want to share your audio and come up and ask your own question, you can do that too. Just let me know in the chat box if that's what you want to do. Otherwise, it'll be for the most time the four of us on screen. So feel free to get those questions going in the chat. So Terry, over to you first, if you're ready to go ahead and share your slides, and we'll start to kick off. So thanks, let's go ahead.
Hi everybody, and apologies up front for that banging you might hear in the background is not our office, it is the house next door to me. So apologies for the bangs that you're going to get in your ears there. Today, weirdly, we're talking about transitioning the grid, but there's an essential part of the grid that's got to deal with all of these transitions. So Aurtra is an IoT and software as a service company focusing on transformer assets. Now, they represent the largest slice of utility asset investment. And strangely enough, they are intriguing because for a couple of things. Transformers have an average life of 40 years. The average life of medium to large transformers in the Australian market is about 35 years. So we're right at that end. In the US, it's actually greater than 40 years. So you have an aging asset that is just as critical in the new wave of the grid as it is in the current wave. It also means that the grid is relying on assets that were developed and installed generally back before digitisation was even thought of. So they have a critical role to play in making that transition of the grid. So the digitisation trends we found, and part of it will be to talk about how 2020 and now are changing that whole equation that we spoke about before COVID. So in the sealed environment of a transformer, I like to think of it as inside the black box. It's really been missed to date in substation and asset digitisation. It is, and the reason is that it's a really hard and dynamic, complex chemical and electrical environment that is supposed to last 40 years. So you've got a really complicated thing there, I like to think of it like Schrodinger's cat, that we don't really know whether the cat's alive or dead, whether it's sick, or whether it's actually going to die next week. So that's what we're all about, is trying to understand the impact on this really critical environment. The other trend, of course, is digitization. Is you don't have the data, you can't actually manage it effectively. And that's either from a replacement CapEx point of view or an OpEx maintenance point of view. The CapEx squeeze that we've seen has been exacerbated by COVID, as it meant that funds for both industry and utilities in particular have been diverted elsewhere into making their service workforces resilient, into changing work practices. And of course, disruptive energy flows from renewables have a major impact on transformers, because as those energy usage profiles change, you get big step changes and volatility as the wind blows and the sun shines or not. And it also means that you have large investment in big generation out at what was at the edge of the grid, where you had these older transformer assets. The other critical thing is that older experienced engineers are retiring. So once upon a time, think about a transformer asset that goes for 40 years and an engineer, you would say, who'd spend his life, his career, and it was a he, in a particular utility or in a particular business. So they actually get to learn and to know the individual characteristics of those transformers throughout their life. They're all retiring now, and so you have a wave of generalists and new engineers and who don't have the opportunity to have the longitudinal knowledge of those key assets. And COVID, of course, has meant that remote monitoring is critical. All of these things mean the time for digitization of those transformers is now. So, as I said, we're an IoT cloud-based analysis. We have a IoT sensor that's in the transformer, expert analysis in the cloud, and our business model is either direct to customers, where they can see our web-based dashboard. Sorry, I've gone to the wrong slide. Then also we OEM to transformer manufacturers and large industrial control companies provide differentiation for our services company partners. So there's a number of different ways that we go to market. From an Aurtra solution point of view, what you're seeing there is our actual sensor. So we have patents in both the sensors all the way through to the algorithms in the front end. So it's a low-cost probe, easy installation in about half an hour by the end user, automated comms, and we have a dashboard. Now, I always like to ask myself, you know, the so what? So, okay, you've got this thing, it's digitization, but what's it actually going to mean for me? So what it means is that you can see for a particular transformer the automated risk rating of what you need to be looking at, whether I need to be worried about this particular transformer of the thousands that I might have in my network. I can get automated complex analysis. In this case, the water content of the paper, that's the insulation in the transformer. It's the breakdown of that paper and electrical failure that's actually going to make the transformer and then the grid around it fail. We have embedded standards because engineers like to say, I'm working to IEEE or IEC or SIGRE standards. It tells you what the impact is. So in this case, if you have rapid load changes, you've got a much greater risk of failure in this particular transformer. So you go out of your way to try and smooth the transitions with this particular transformer. It gives you recommendations on what you should do about it. And for those young engineers who are trying to learn about it, it then gives you more education. So with any new thing, you think, well, you know, is this a thing? Does it resonate? Do people actually want it? So this is a map of our Aurtra customers around the world. You can see that we started in Australia and we've got 10 utilities there, as well as our OEM partners and industry and utilities around the world. The great thing about Australia is that as a world-class industry, it means that knowledge that we have here and people here are directly relatable overseas. So what's that meant in 2020? It's meant that we've managed to get significant traction with industrial control conglomerates because we seem to be relatively unique in looking at inside the transformer, not just with data, there's plenty of people who do that, but answering the so what, and what does that mean for my maintenance and my replacement schedules? There's multiple business line value propositions there, both from the software to the services to digitization of the transformers themselves. In 2020, we started a number of co-branded trials around the world. And it's exciting because at this quarter, we're actually in the negotiation phase to roll out OEM through those big industrials globally. We are at the moment raising a convertible note and for a little bit of funds before we then go and scale on. So, you know, really 2020 has been great for us because when the everyday stops, there's a lot more room for strategic thinking. And we've been able to reach the leaders in industrial control and in our customers around the world because they're sitting at home and thinking, how am I going to deal with this challenge going forward? So thanks for that. Happy to take your questions.
Thank you so much for that, Terry. That was a really great understanding of Aurtra and some really fantastic progress that you've made throughout 2020, which is no mean feat, that's for sure. So if you'd like to ask Terry a question, make sure you're sitting on the chat for the session. Just type it on in and we'll be doing those later. But next, I would like to hand over to Chris Cox, who's the Managing Director and Co-founder from Infravision. So Chris, if you'd like to share your screen, you go ahead.
Will do. Thanks, Megan, and hi everyone. It's great to see such an awesome audience today. A lot of people here, so I'm looking forward to letting you know a little bit about Infravision. Just confirm you can see that there for me, Megan. Is that all coming through okay?
Perfectly great, thank you.
Awesome. No worries. So I guess I'll just kick off. Infravision, we exist to reduce and to target legacy risk problems associated with the construction of power lines, the maintenance of power lines, and then moving into assisting with how to assist with connected intelligent networks and how our hardware solutions and our software solutions may be able to help people. My co-founder Cameron is an electrical engineer, and I am an ex-military combat officer and pilot. And together, we've developed a system which essentially pairs winches, drones, power supplies, and a software set that allows tension stringing of power lines to be conducted without the risk or with a much greater reduced risk to human life on the worksite. And we've been recognised for this essentially throughout the last 18 months. We've been working closely with a number of major utilities. Specifically, I'd call out Transgrid over the last 12 months in developing this and being able to utilise these systems on real life projects. And now we're in the commercialisation phase of this technology. Just zooming back to what the real issues are, is that really traditional methods for power line construction and maintenance are inherently risky, and they expose the workforce to high levels of risk in both working at height and operating complex machinery in close proximity to structures and towers and ground crews. Tragically, in 2019, a pilot was killed conducting stringing activities, which is something similar to the top left photo that you can see. And this really saw Australia start to shift away from close proximity helicopter operations for the construction of transmission assets and the maintenance of those assets. And Infravision was called to assist and create some technology that might be able to solve this problem. So over the last 18 months, we've developed a system called the TX system. And what it is a drone package that's developed for the customer. We have a drone agnostic approach, so we can integrate with any drone on the market. We have a patented network smart winch and tensioner, which has a software suite that allows it to essentially talk to the drone system and maintain tension as the drone is flying. And then we have a modular ground control station and off-road trailer. And this also has a power supply unit that can either be electric or diesel, depending on the market. The winch tensioner itself is actually built with electric car technology. It's actually driven off the same drivetrains. So we can attain very high speeds and high amounts of torque with the winch, which aren't traditionally seen on the work sites. And finally, we package all this up in a 20-foot shipping container because that's what the industry moves to and from site with, both nationally and internationally. As you can see here, we've designed the system to package up for easy deployment all over the world. Our smart tensioner lives in the rear. You can see the HMI, or the human machine interface panel. We have a power supply in the middle, and the drones deploy from the front compartment, and all the charging and fire retardant componentry is also in that front compartment to allow for easy deployment in some of the harshest terrain environments. Here's just a photo of just showing you some of the air machines we use, and that can integrate with the Infravision TX system. We know the drone industry is moving very fast, and supply chains specifically are constantly evolving. So at the core of our technology, we've really adopted a drone agnostic approach. And what that's allowed us to do is talk to many different drone providers across the world and use them as potential channel partners as we look to expand. And finally, look, we've really solved the remote deployment challenges by engineering an off-road system for the drones, winch and tensioner. We, being ex-military and Cameron from the Powerline construction environment, we have a really good understanding of the remote locations this gear needs to work and the sorts of support it needs to be able to operate independently. So how does it work? Essentially, the drone pays out line. The winch pays out line to the drone under tension, and we can automatically set that tension as the drone flies forward. It hooks up and it hauls back synthetic line or conductor directly to the location. And that's essentially how the power line gets strung. There's some intricacies into the method, but essentially that's what we do. And finally, we can have multiple TX systems operating on the same power line. So where productivity requirements or productivity dates and are really targeted, or where there's a requirement to move faster for a build, if you need an outage for a certain window and that's costing the job a lot of money, this is where these things really come into their own. The deep technology that really rounds this out is the ability for that system to talk to the drone and allow that winch and tensioning system to negate the need for easement clearing. It's a little bit about how we're different. So we reduce risk from the traditional methods right now, especially the aerial methods. There is this catastrophic residual risk presented by aircraft that crash, not only to the operators of the aircraft themselves, but to the ground crews. They're very capital intensive, and they're also very high impact in the way that it's very difficult to work around machines that are weigh in excess of a ton and are very loud as well, kicking up lots of dust, disturbing livestock, disturbing crops. The alternate methods from aerial stringing include easement clearing. And as you can see in the middle photo, that's what's required. And funnily enough, the lost time for injury for jobs like that is actually increased when you're looking at the amount of manpower or work that's needed to be able to move through and clear environments such as the one you can see in the middle. Some environments can't be cleared in this way, specifically, for example, the snowy mountains. There's some easements where you really just can't get a bulldozer down, and you're only limited to aerial methods of construction. And once again, not only for state forests, we provide a bit of benefits for the local farmers as well, for their crops and livestock as we're moving through and constructing these power lines. Look, here's just a photo of one of the jobs we completed at the end of last year. Just a shot of 2 spans. The span ahead is around 700 meters. Power line on the right is constructed utilizing 1990s traditional type methods of both aerial stringing and ground clearing. And the power line on the left was constructed with the Infravision TX system. When we're looking at the national market, there's over 4,500 kilometres of power line that needs to be constructed over the next 5 to 10 year term. So there's a lot of work, and it's actually the most amount of work that's been done in Australia since the 1940s transmission boom. So it's really interesting it's a really interesting space for us to be playing right now. This isn't a trend that's local to Australia though. In the last 10 years, 9 million kilometres of transmission and distribution line was constructed across the world, and that's expected to grow to 16 million kilometres over the next 10 years, with India, Brazil, Mexico, United States and Canada being some of the biggest users, of having the biggest requirements for their growing populations and growing energy needs. So a bit of a health check about Infravision. We're 100% founder funded owned, and we have 20 plus staff. We're growing, profitable, got patents pending for a lot of our technology, and we've got multiple revenue streams. We've got monthly recurring revenues coming from long-term leases for our system and operational software packages. And we also do traditional service contracts with network owners and tier 1 contractors. And really what we're doing now is we're looking to raise capital to scale internationally and capitalize on our first mover advantage and really get these systems out to the world so we can drive the outcomes and drive this, this push to a sustainable future, which is great because it's really gearing up right now and helping other nations of the world electrify. Our leadership team is primarily ex-veteran and ex-construction, and we also have people from the software business as well supporting us, and people from aviation business such as Qantas running our operations in the field. So a really well-rounded team to be able to tackle the challenges, not only building the technology, but supporting the technology, conducting the research and development to move it forward and to grow it, and then projects if that's what the customers need in the field. And that's all I got today. Thanks.
Fantastic. Thanks, Chris, for sharing that. Some really incredible images there, particularly the differences between what you do using the Infravision product versus what somebody would normally do stringing power lines. So thank you very much for that. We will move on. More questions for Chris. So if you want to ask Chris a question, please pop it in the chat. So for our final presentation today, we've got Alex Post, the CTO and co-founder from MGA Thermal. So Alex, if you would like to share your screen and kick off your presentation, we're ready to go.
All right, thanks, Megan. That's coming through okay, is it?
Yes, that's perfect. Thank you.
Awesome. All right, thank you everyone for coming along today. I'll dive straight in. So I think everyone's already pretty well aware of this, but we're going through a massive transition at the moment with our global energy grid and how we generate and use electricity. So traditionally, the world's relied on sources of, combusting fuels, which you can do around the clock to produce energy and very easily match your supply to your demand. So you can generate energy exactly when you know you need to use it, and you don't have any need to store that energy in the meantime. Now that we're moving to renewable sources like wind and solar, we have a supply of energy that occurs at a certain time, which may not be exactly when we want to use it. So the massive problem that's emerging as we transition our grid so rapidly is that we don't have the capacity to store all of this energy to meet our demand around the clock from our supply, which in the case of solar is available for about 8 hours a day. In the case of wind, varies over day and night. So obviously there's a massive need for storage that's very, very quickly emerging. There are a whole bunch of different energy storage technologies that are already on the market, and people are taking a range of different approaches. We're seeing batteries spring up all over the world, which is supporting the grid very, very well, especially in short-term intermittency issues. There's a very, very strong push towards hydrogen, in particular clean hydrogen generated from renewable sources. Hydroelectric has been a big player for a long time, and thermal storage has always been putting along, supplying heat for industrial processes and sometimes for power. Now, what we do at MGA Thermal is we make these bricks which are a patented and newly invented type of thermal energy storage material. So we're a team of material scientists and engineers who set out to make a material, engineer it from the ground up to make thermal storage much more achievable. So traditionally, we've relied on molten salt for our thermal storage, which is basically a gigantic tank of salt, liquid salt, which stores energy, and we can extract that energy to drive a steam turbine and generate electricity and so on. It has a few problems. For instance, if you heat up this salt too much, above about 500 degrees, it decomposes, so you lose all of your salt. If you allow it to cool down, it freezes at about 250 degrees, in which case all of your heat exchangers, all of your pumps, all of your machinery are full of solid salt, which has a very, very low thermal conductivity, and basically means several month downtime of cutting apart machinery, removing salt crystals, and setting everything back up. So that's quite a catastrophic event. And because of that kind of complexity, people have often shied away from thermal energy storage, even though about half the energy we actually use, especially in industry, is as heat. So it makes a lot of sense to store energy as heat if we can do it effectively. So we've invented a material that has the properties that you need to make thermal energy storage very easy. We have these inert bricks, which basically sit there. They don't melt, they don't freeze, they can go all the way down to room temperature. You can overheat them by hundreds of degrees, nothing happens. But they store a lot of energy because within those bricks we have grains of metal which melt at a certain temperature. And that melting stores a whole ton of energy. But you never actually see the bricks melt because everything's encapsulated within this solid matrix. So what we do with our bricks is we can charge them up using a range of different renewable sources. We can use electricity, which has been generated by solar PV or wind or concentrated solar thermal, or it could be a waste stream of heat from an industrial process. And all of that energy is captured as heat within our bricks. We heat them up to about 670 to 700 degrees Celsius, so they get very, very hot. And when you want to use all of that energy, you can dispatch it in a number of ways. So we can use all of that heat to generate steam, which can then run a thermal power station without burning coal. That's the application that we're most excited in at the moment. We can use it to provide heat for an industrial process, like heating up air to dry something for food production. We can use it for residential and commercial space heating. So there are a whole bunch of uses for energy once you have it stored as heat. And because we're using readily available materials, so we actually make these things out of predominantly recycled materials, which are waste products from other industries. They're available at a very, very low cost. So there's nothing there that's exotic or rare earth or anything like that, which is a limited and expensive resource. They're quite a low cost commodity. Now, capturing all of the markets that I just talked about is a very difficult thing for a startup company to do. You know, we're talking about different embodiments of the tech for hydrogen generation, for providing heat for industry, for providing electricity. And there's a ton of engineering behind that, which people have already figured out and can already do very, very well. So because of that, we're focusing our core expertise on the material science and making our blocks as effectively as we can. And scaling up that manufacture. And we're distributing that product, which is just our modular bricks, to a whole range of different integration partners for the different market segments that we plan on targeting. So we've already partnered with a Swiss company called E2S Power, and those guys are focused on retrofitting coal-fired power plants in Europe. So to elaborate on that, Germany in particular has mandated the shutdown of all of their thermal power stations in the next 10 years. Which means billions of dollars of stranded assets on the grid, which haven't reached the end of their life, but because of the shift to renewables, we don't want to use them anymore. And what we can actually do is repurpose all of that infrastructure, or the large majority of it, including the generator, the turbo machinery, the grid connection, and use that to dispatch stored heat from our blocks as electricity, rather than building a huge energy storage system from is a very expensive and slow exercise, and isn't going to meet the demand for storage that we need right now. I'm not going to go through each of these, but we're partnering with different organizations to try and target each of these different market segments and roll out our products from day one to a large global market. So since starting the EnergyLab Scaleup program, we've hit a few milestones. We've expanded our team to 8 full-time employees with a very strong R&D and engineering background. We've had a large media release last year where we hit over 237 million global impressions and had a story reshared through over 50 different media outlets. And that was targeting our repurpose of thermal power stations. We've also moved our company HQ to a large industrial shed where we can actually set up our commercial manufacturing, which is underway at the moment, to start to service some of these large projects. We've signed a MOU with a distributed storage product. So there's this transitional market that's going on at the moment, but long-term, the grid is moving towards distributed energy generation, and we'd like to be there when it happens. And we have a pilot underway, or the planning of a pilot underway with an Australian utility. So we're going to keep a strong presence right here in Australia, keep our manufacturing here in Newcastle in the Hunter Valley, and try and push forwards on Australian pilots, as well as expanding overseas. We're currently raising capital in the next coming months. So the aim here is to raise between 7 and 10 million Australian dollars, with the goal of expanding our team, expanding our manufacturing capability to deliver on some of these projects, and acquire our IP, which is currently sub-licensed from the university where it was invented. KPIs are to meet our first commercial deployments of the technology, to unlock a new high temperature MGA system, which opens up whole new ways that we can use the tech, and to deliver on supply agreements to 2 major customers in the order of $10 million US. So here's the team. It was great to have the opportunity to talk to everyone, and looking forward to answering some questions. Thank you.
Thanks, Alex, for that. That was an excellent update and some really exciting things there, definitely for, turning some of our aging infrastructure into something that's more appropriate for the future. Now, did you have that brick there today?
Yep.
Did you show it? Show us, because I think it's exciting.
It around.
It looks like a brick. Thank you so much. Now, so I tell you what an exciting startup ecosystem we've got going on in Australia. Really just mind blown with things that have been shared today. So thank you, Terry, Chris and Alex, for sharing your presentations. We have got a range of questions, so I am going to start going through those. I've got questions of my own, but I'm willing to put them on the back burner so that everyone else can ask their questions. So our first question is from Josh Smith, and it's for you, Terry. How has Aurtra found the manufacturing process through development of the probes? As a developing company, has the manufacturing process been able to be managed mostly in-house and in-country, or has the outsourcing of this been more palatable? Manufacturing is always a hot topic, particularly since COVID, I think. So over to you, Terry.
Great question, Josh. So yes, always entertaining in COVID times. My co-founder Richard and I have both been in startups before, created hardware and sent those globally, so we sort of understand how that works. So what it has been, though, right when COVID was starting, we were looking to move our bulk manufacture of the sensor over to Thailand, not China, for obvious reasons. Had to put that on hold, and so it's all been here. With regards to the sensor is, we have around the sensor originally, way back in 2017, we third-party sensor. Now we incorporate 3 different lots of temperature, moisture, RF for partial discharge and vibration in the one sensor. And so the sensor itself is made under license for us in Europe by a third-party manufacturer. It comes back here, all the electronics we do here, the housings we get from otherwise, and we put it all together, calibrate and do that, and we're shipping globally from Australia at the moment. So once, from a scale point of view, once we can travel, God knows when, we will send our young engineers over for the trip of their lifetime, where they sit in a factory and get everything going overseas, and which we all did back in the to actually get projects going. So certainly at the moment we're shipping from here, which honestly has been a big benefit from a COVID and other point of view, because as a safe place to be shipping from, and things have continued. So yep, we continue to ship both our hardware from here and develop all of our software in Australia.
Thank you very much for that, Terry. Next question comes from Tim Blundy. And Chris, I know you've answered this on there, but you might just like to give a little summary for everyone. What is the impact on bushfire risk of the power corridors? I'm assuming he's talking about the ones that aren't cleared because they're using your technology. So if you want to have a go at that, that would be great.
Yeah, great. I'll just preface this with I have no experience in fire safety planning, so it's not one of the areas that I'm an expert in. But I'll try to answer the question in two ways. And we deal with the transmission network service providers, construction, tier 1 construction, and we also deal with the government agencies. So I've got a fairly sort of broad understanding of some of the concerns they're looking at. So first of all, when we're looking at the fire easements being used as control corridors, or corridors where firefighters can actually fight and conduct, or essentially a fire break to limit the spread of a fire. We just need to remember that the power lines that are going up, they require semi-trailers minimum to be able to conduct the construction and move to the sites where the structures are going up. So there'll always be a requirement for a road that can facilitate large, heavy vehicles up to bulldozer size to be able to clear the large pads every 10 kilometres, and each structure around 50 to 100 metres or so. So it's just important to remember that those roads must be constructed either way, because there's hundreds of tons of materials. Sometimes, a roll of conductor can weigh up to 5 to 10 tons before it's even moving through the air over 2 kilometres, depending on what the size of the electricity profile is for the power line. So those can still be used as corridors to conduct the firefighting activities. Where there's areas of high risk, they may deem high risk, they may still want to construct a corridor, then of course they'll do so. So, human life and the well-being of Australians is always at the forefront of our minds, especially from what happened during the 2019 and 2018 fires. Fire risk to conductors is an interesting one though. So when we're talking about some of the costs that are incurred during power line construction, the biodiversity offsets that have been initiated by the federal government in 2014 require a certain amount of money to be essentially paid every time you want to cut down certain natural and native species. So what we can do is we can either lower essentially the canopy height, and certain specific trees will be cut down to facilitate that, and engineers will work to establish a minimum safe approach distance from the top of the canopy to the conductor, where they say basically we don't think the flames will touch, therefore it's fine. And there's two ways they can do that. So they can either lower the vegetation, or they can increase the height of the canopy. In both scenarios, you need a full tension stringing method and system. Even with some of the traditional aerial assets, you're still required to haul the follow-on draw wires across the ground and conduct a full clearing scenario. We can kind of, to give you a feeling of what that looks like on a major project, it's in excess of $100 million for 1,000 kilometres. So those are the sorts of numbers we're seeing right now on the biodiversity offset scale and a full clearing scenario.
Great.
So yeah, hopefully that answers your question there.
Thanks, Chris. That's good. We can always come back. If it's not answered, please feel free to pop it in the chat and I will get to it. There are some more questions for you, Chris, but I'm going to move down to one for Alex, which is from Stephen Turner. Could MGA Thermal's technology be integrated into supercritical CO2 turbines, e.g. 700 degrees and above, with 50% turbine efficiency? I hope you know what that means more than I do.
I do. So the supercritical CO2 turbines are a very interesting tech that's starting to come onto the market at the moment. And the niche that it fills is normally for a steam turbine, you're limited in efficiency if you get below the kind of power plant level scale. So, you know, anything below sort of 50 megawatts, which is still a pretty big unit, you're looking at efficiencies in the 20% kind of thing. So with supercritical CO2 turbines, they're much more compact, they run at a much higher temperature, and you can actually have turbines in the order of sort of 1 megawatt, which are, yeah, pushing 50% efficient, which is just this massive niche in the market that hasn't been filled yet, because no one can make distributed turbines for small scale, you know, end of grid, or sort of mine site consumers and that sort of thing in the 1 megawatt range with turbo machinery. So yes, we're definitely aware of supercritical CO2. We have, so these bricks that I showed earlier operate at 660 degrees, which is not really unlocking the full potential of a supercritical turbine, because they're sort of in the 700 plus range. We have a new high temperature system under development, which is specifically targeted to use supercritical CO2 turbines. And we have a partnership with a US-based company at the moment, mapping out development for a co-offered product, which is using supercritical CO2 turbines. So it's definitely a space that we want to be in. I think it's, in terms of turbo machinery, it's going to mirror the movement of the grid towards distributed generation, and it has the ability to have high efficiency when you have distributed generation. So very, very interested about that application.
Fantastic. Thank you very much, Alex. That was great. I'm actually going to throw a question of my own in there, as the moderator has the right to do. So my question's actually for Terry, because just before, in answering the question you raised about overseas manufacturing before, you've obviously got experience in global markets. So how does the experience that you're having in the Australian market right now, how's that translating globally? What sort of feedback are you getting?
Yeah, so actually it was the thing, right started about kicking this off back in 2017. The reason we thought that we could create a startup here is because we have a world-class industry here in a microcosm that is accessible, but also an industry that is very collegial. So if I talk to engineers at Energy Queensland or at any of the smelters or whatever, they are all part of a very collegial club. They'll talk to each other, you know, we'll be able to get great feedback. And so it meant that being close to early days, having very responsive customers who are actually happy and interested to be innovative and to give you a lot of feedback, but while you're testing your problem in this market, that then allows you to develop your product. And what we found is that it is a global need. It's quite homogenous. The transformers are the same. The problem is the same globally. You know, we have installations in Russia and Colombia and Europe and all sorts of places. And so it is exactly the same problem. And so it's been very valuable for us to have the environment of Australia to actually test that market while being a small part our TAM, our available market, because it's meant that we can get things right here, then you've got the global market to go to, and you're going there, say, you know, a fully developed product that you can scale up.
Much for that, Terry. It's just, yeah, really interesting how the world's both small and big all at the same time. So we have got another question for Chris, and my brain is not finding it, but it will any second. Here. Ah, this is it. I knew it was a good one. Do you consider your tech is finished development, and do you have significant challenges remaining on the tech side?
Nothing is ever finished. So in terms of, is it operating commercially and have transmission network service provider customers taking delivery of systems, and are they working? The answer is yes. So we're out there, we're building greenfield power lines right now, and we're working on some of the we're working with both transmission network service providers and principal contractors on some of the biggest projects that Australia has coming up in the next 12 to 24 months. So commercialized, yes. Is it finished? Absolutely not. You know, the biggest drone in the world, or the most highest powered winch, whatever method removes as many people as we can get from the risk element of the operation, and however we can automate that to a position where we're able to effectively deploy these machines, not only to first world countries, but to third world countries to go and conduct construction. Where Infravision's really focused on right now is we've got a partnership or a working relationship with Papua New Guinea Power. They have an electrification target of 70% of their population by 2030. And right now they're at 17%. So really our systems and our personnel, while we can send teams overseas, it's really the automation focus of being able to deploy a system into an environment, have someone over there to understand it, be able to open it up, and it can go and conduct those construction and maintenance tasks autonomously. That's where we want to move, and that's really our focus over the next 3 to 4 years. So removing the people from the risk element of the operation and removing them from the requirement to deploy is very top topic right now, and also changing the methodology of how transmission lines have been constructed since the 1920s to a 21st century approach. I believe that is a 10-year push right now. That is a 10-year push, and that's a push that we're undertaking time now.
Great, thanks for that, Chris. So I think Tim, I got the answer. Yes, they are finished, but there's always more work to be done. But it is out there, and this solution is out there and working for their customers. While I've got you there, Chris, I've got another question from Stephen Turner. So what are the financial benefits of the Infravision solution versus the traditional methods of stringing power lines?
Okay, there's a few financial benefits. First of all, when you think of a helicopter that can pull power lines, you're thinking of a $3 million to $5 million asset straight away before you even start. Then you're thinking of a pilot that requires around 5,000 to 10,000 hours. The value of the pilot's training and hours to actually get to the level where he or she can actually conduct that activity could be in excess of the actual asset itself. So really what you're seeing in front of what I've just presented is a much more cost-effective solution, not only in the total capital cost of the asset, but also the training requirement for the teams that can actually operate those systems. The second component is these systems can go out onto a site and actually can be working with the existing work crews. So we can upskill work crews. The last job we did, we trained our pilots in around 2 to 3 weeks, give or take, from being REPL certified, which takes around a month or so. So our pilot training pathway to actually get these things out there and doing the work is very small. So what that means is you've got an asset on site that can sit within your construction program rather than having a high value asset coming in and doing very expensive work for short periods of time. Builds flexibility and float into a construction program that has an unlimited amount of uncertainty. We can operate multiple TX systems on either side of the power line, which means that essentially you're getting a double productivity bonus. Previously, it's quite dangerous or risky to do that, with the traditional methods as well. And then finally, the ground-based methods, as we're looking forward into the future, not everyone can get aerial helicopters. There's significant issues, once again, in third world countries, and there's significant issues in places like South America or the east coast of Africa, where those assets and the people to do those activities aren't available, so they have to resort to ground-based methods. And our methods are more productive than ground-based methods, as well as the aerial traditional methods that are out there. So it comes down to productivity, cost, and removing an element of the workforce or upskilling an element of the workforce to be able to conduct those activities. Hope I kind of answered that. I'm really keen to dive into it if we got time at the end.
Fantastic. Thanks for that, Chris. I think if we're not happy with the answer, you can always just pop up and you can have a conversation. So just share your audio when we get. Next question is over to you, Alex, which is, when will your tech be ready for deployment? Do you have any pilot partners lined up? Stephen Turner, I'm not sure if that's an offer or not, but I like it. So over to you, Alex.
Thanks, Stephen. So we're close to finishing the commissioning of our pilot manufacturing plant, which has been funded by the Australian federal government through an accelerating commercialisation grant. So that production line is due to come online in mid-March, and it's basically geared towards producing a quantity of our bricks which is applicable for pilot scale demos. So it's definitely the next hurdle for us. And if it is an offer, awesome, super keen to conduct as many pilots as we possibly can. And yeah, we're basically targeting about 1 megawatt hour of storage capacity per month is our initial production rate, and we're going to incrementally scale that up throughout the year. So depending on the size of the pilot, it might represent a month's worth of production. So a megawatt hour is a decent sized storage project. By the end of the year, we'd like to be targeting sort of 50 megawatt hour storage projects, which, to put that in perspective, is about the size of half the Tesla battery in South Australia, the Hornsdale Power Reserve. So we are targeting the very large end of town because that's where, I mean, that's our initial market. It's retrofitting coal-fired power plants, which is an order of magnitude larger than this again. But our technology in particular is well suited towards large-scale projects. Hopefully that answered it.
Fantastic. Was really good. Terry, I've got a question for you. Having worked in a transmission and distribution company before, outages are not desirable at any time, either accidental or taken for maintenance purposes. In terms of your IoT sensors and your solution, what do the crew need to do to install them, and are outages required?
Thanks, Megan. Good question. So we're manufacturing and supporting this software. It's fortunate for us, to be honest, that our customers want to install it themselves. So they want to do that. They know their assets. They have their own work processes and things like that. So our aim is to make this as seamless and as few barriers to entry as possible. We want to make it super easy to install, really cheap, and take no time at all. We want to make sure that they've got to think of a reason not to do it rather than the other way around. Sorry, it's pouring here in Brisbane all of a sudden. It takes about half an hour to install automated comms. If once you've got low voltage power to it, 24 volts to it, it will just start talking to the cloud and come on. If you're installing it in the bottom of a transformer, generally you're far enough away from the high voltage that you don't need to have an outage. Or what we find is a lot of those who want to install it closer to the top, they will go and look at their next planned maintenance window and then install it at the same time and go from there. So yeah, generally, from a straight pricing point of view, where our list price is $200 a month going a month with volume. And when you're talking about transformer assets, you're not talking about a large investment to understand the criticality and health of it.
Thank you, Terry. Next question is for you, Chris. So how has Infravision found the challenges as a startup of managing scaling up the workforce and associated costs with securing clients and associated revenue? As a purely founder-funded company, congratulations, which is super awesome. I find this a great achievement, as do I. So that's your question. How have you managed that challenge?
In the messages, we really, really focus on a very small market vertical that's very high value, and the problems are very real in both risk and environment. So that's pretty much what we do. We sometimes look at other options, and many people ask us to solve a whole lot of different problems for them, specifically in the transmission network service providers, because we do fly drones, and we were previously or very focused on conducting condition assessment in the red ocean that is, but we're very focused, and then also we execute very well. So we really worked hard to get a team of ex-veterans, ex-construction engineers, and then round that out with additional aviation experience, and then the experience from startup land for people like Luke and Nia and Adam from Uber. So we really kind of had a great team to be able to go out and execute well. I believe that in the construction industry specifically, it's very hard to enter unless you have some sort of experience or background to be able to back it up. And I think the veteran side of the business and the ex-tier one construction side of the business allowed us to break down some of those barriers initially. but we still had to be able to prove and do what we were doing. So how do we do it? We hauled the industry through the gap with us. We were very picky about who our customers were, how they would focus. We worked very closely with Transgrid, as I probably previously said, who foster a great innovative environment for us to be able to go out and make mistakes and learn fast. And it was really a key decision for us to focus right in on them, because they were the right customer to be able to increase the technology and the roadmap and allow us to succeed. Bootstrapping, look, I haven't got grey hairs yet, but there's a tipping point where you do need capital to be able to grow, and we're quickly coming up to that tipping point right now. So hopefully that answered the question.
Oh, fantastic. Thank you, Chris. I think that's great. And the next name on the list I'm going to make a mess of, so I apologise to this person right now. I would say Fiatia, but that is probably wrong. What is the thermal mass of the brick, Alex?
So I've kind of already answered that in the chat, but the mass is about 1,800 kilograms per cubic meter, or the density, and the amount of heat that you can store in the brick depends on what operating temperature you're going between. So because we use a phase change, so we actually have a component of our material melts at exactly 660 degrees, and that's where most of the energy is stored. But there's also a component of sensible heat, which is basically, you put heat into something, it increases its temperature, that's sensible heat. And as you withdraw energy from it, its temperature decreases. So that's the normal way to store thermal energy. And because there's a component of that on either side of the phase change, the total energy storage capacity actually depends on how much you care about going over 660 on the hot side and below 660 on the cold side. So it's a little bit application dependent, but we normally quote energy densities using 100 degrees of sensible heat on either side of that phase change. If you wanted to use the energy all the way down to room temperature, then you get a whole lot more. But for most applications, you're not interested in heat that's at 50 degrees. So with those numbers in mind, we normally quote about 250 kilowatt hours of energy storage capacity per cubic meter. So apologies if this is getting very engineering. But to put in perspective, that's 4 cubic meters for a megawatt hour of storage, which is several times more dense than batteries.
Okay, Alex, and while I've got you there, and forgive me if you've already answered this, from Chris Wilson, what's the expected round trip efficiency of the brick in a retrofit installation, and what storage duration niche are you aiming for primarily?
Great question, Chris. So that's limited by the efficiency of the thermal power station, which is typically about 35 to 40%. So round trip, that's basically your efficiency. The charging step of electricity to heat is very easy to do efficiently, because most electronic processors have heat as your source of inefficiency. Any energy that you lose is normally in the form of heat. So converting electricity to heat, very, very easy. Converting it back is quite difficult, which is partially why the CO2 turbines are so interesting, because they're much higher efficiency. So having a round trip efficiency of 35% isn't fantastic, obviously. And the caveat to that is that the market niche that we're targeting is basically when you have excess energy available in the middle of the day, which would otherwise be curtailed. So in that instance, you're not actually overly interested in your round trip efficiency. What you're interested in is how quickly you can soak up all of that excess energy that's just being switched off otherwise, and how quickly you can get it back out onto the grid. So it is targeted not necessarily at high efficiency, but at high quantity, high duration. And we're targeting sort of like cycled once per day, but about 8 hours of storage for that application.
Now, I've got a question that's relevant for everyone, actually, given global market. So what's the biggest help? This is from Mick. What's the biggest help you get to help you get traction in the bigger markets like the US? And do you have the teams to do it? So Terry, we might start with you. What's the biggest help you could get? I'm assuming that's a call out for support. So I think you should go for it.
Yeah, as I've said in the thread, you know, honestly, we found in 2020, the US is a bit of a basket case. So sorry if I've offended anyone there, but honestly, they've pulled in their horns more than any other sort of jurisdiction that we have. So COVID aside, we've had a VP of America in Atlanta for the last 18 months. At the moment, actually, we've sort of targeted him at Latin America and Spanish-speaking Europe, because we've actually had much better traction there, and being in the time zone, that's okay. But the main thing from a go-to-market point of view is when you're trying to target utilities or large industry or something like that, is to go to somebody who's already talking to them, who they already trust. So we've got this dual channel partner strategy. So it might be someone who's doing services for them or something like that. So certainly finding those people who are from the market, who understand it, to go and say, actually, these are the guys of influence in this particular market. Because particularly when you're selling a technical product to technical people, you know, they hate being sold to. They want someone who's actually going to not bullshit them and to tell them, actually, this is a thing, you should give it a go. And so you need to build that network of trust. So trying to find people who actually have a big enough network in your target industry, I think is, you know, the biggest challenge that we find.
Terry, and Chris, over to you. I think you've got a really big pipeline anyway. I'm not sure if this is your challenge right now, but what's the biggest help you get to get some traction in some of those big markets overseas?
Yeah, so thanks Megan and Mick for the question. The beautiful thing about major projects right now is there's only a fairly small number of international tier 1 construction firms that can conduct those projects, and they do so on an international scale. And they'll generally align with different products, different conductors, different steel manufacturers and providers. So we've been doing an Infravision specifically around targeting that with the view to grow, is to look at those people with the greatest international reach and really talk to them. So we talked to a supplier in Australia who basically installs all the insulators, dampeners, and pretty much everything you see on a power line that isn't the ladder steel structure and the conductor is an American company that's been around for around 70 to 80 years. So we're really working hard to have them as a channel partner, and they've got a service provision and drone operation division over America. So that's kind of how we're looking at that to enter the market. The beautiful thing as well is that our systems can integrate with any drone out there on the market. So Infravision has spent months overseas searching for the best systems, and what we're finding now is the people who've spent their lives building aircraft to carry a heavy lift drone in a commercial environment, we're literally the best use case there is, and they're very motivated to go and see those machines flying in their own environment. So we have Norwegian aircraft that are currently being used in Norway for commercial activities. We have those, and we utilize those here, and they're actively out there pursuing the energy industry and StatNet. We're doing the same thing with a construction or a mob called Parallel, for example, in the USA, who's based in Silicon Valley, ex-SpaceX and Tesla engineers. So we're trying to utilize those relationships. And during the course of this raise, I think we're really looking for an international investor who's got their roots in those sorts of markets, in the energy markets specifically.
Thank you for that, Chris. And Alex, over to you. What about getting traction in some of those bigger markets? I know you're already getting traction in Europe, but what's the biggest help that you could get to get some work done there?
So the immediate thing that we're looking for is the upcoming capital raise. So introductions to more investors, both Australian and international, for that would be fantastic, especially investors that have some experience in clean energy tech and manufacturing. So we'd like to, take smart money, which has leads into project partners and that kind of thing, as well as people who are just socially interested in the use case. The other thing that could be useful is it looks like for the near to foreseeable future, we're probably going to be limited basically by how fast we can make our material. So sub-licensed manufacturing overseas is definitely something that we need to start laying the groundwork for now, and we're delivering on large US and European projects. So partners for sub-licensed manufacturing, I'd be very interested in getting in touch with anyone who's interested in doing that.
Can I make a comment that the three of us have answered that question and about going overseas, and not one of us have talked about the fact that we can't travel. Like, this has become so normal, we didn't even mention it. You know, the fact that we're doing all of this and it's, you know, sitting in your house. Yeah. So it's worth sort of sitting back and saying, we're actually talking about from Australia, and previously the tyranny of distance, and, you know, we've gone and spent time in the valley and doing all of this stuff. But actually for Australians, being able to, you know, sharpen our skills about going overseas while not leaving home, it's probably a great advantage to us all.
It is, and it's incredible that it's still been able to continue. All of you have got equipment, so it's not a software as a service where people just type it. You've got things that you need to get into other countries, and it is still, you're still all making progress. It is amazing. And I think before what's happened in 2020, I'm sure we all have said, oh, that's not possible. But getting around it's great. And it does. It's like, well, now maybe Australia's not the disadvantage we all thought it was. It doesn't. We get to have this wonderful lifestyle and still do these incredible things. Okay. Now I think I've got everyone's questions. If I have not got your question, please put it in the chat again, because I have missed it and I am sorry. So please pop any more questions back in. There's a comment from Mick about capital raising. I don't think that's a question. I might take that as a comment. but please pop anything else in. Look, I'd really like to ask each of you, actually, you're operating in this amazing ecosystem in Australia around energy. We, you know, over the last few years in particular, this market has gotten really interesting when it comes to energy transition and really embracing the new technologies and what's available. So we're in a great space, and it's such a great test bed, even for companies coming from overseas. I know there's lots of startups that want to come and work here. But what can this market, what can this ecosystem that we've created in Australia do for each of you? You know, if it's finance, that's fine. But what are you looking for? What help are you looking for from this ecosystem? How can we support you to be even more amazing? I might start with Chris. Go ahead.
Utilities and tier one construction and basically the big organizations who traditionally run energy need to really put a focus on how they foster innovation, how they allow for failure, and how they allow for people to move fast. They need to look at and understand better how startups or how young companies are now working, and figure out how they can integrate those companies into their organizations and get the value without restricting them as they're moving forward. And I think there's a shift, and it's happening right now. Some places happening very fast, some places moving slowly. But the more, it's not just having an innovation manager, an innovation person, an executive, and that's what's going to happen. It needs to be driven from the top down throughout the entire organization. And a lot of organizations, it's very hard to get in without just being seen as a subcontractor. And I think people can work towards that as their main focus. That will foster this environment. That will allow, especially Australian innovative clean tech companies like the ones in this room right now, to move faster and to be able to apply their technology to real projects. Because trial after trial after trial after trial doesn't get us to a future where my daughters are going to not have to, you know, realize the problems associated with climate change. It's actually working on projects for real scale things. So I think if that's the focus, that's great.
Very much. And Alex, what about you? What can the ecosystem do for you here in Australia?
I think Australia is a great test bed for new and emerging technologies, which is why we're really thrilled to be based. It's just getting in touch with all of those early adopters and other people within the ecosystem who are willing to try new technologies, especially because we're commercializing a brand new material. You know, obviously that's about as unfamiliar as you can possibly get with something new on the market. Yeah, so just all the crazy Australians who'll go out there and try new stuff.
Sounds good. And Terry, what about yourself? How can this ecosystem and the humans that are operating in it help you?
Actually, mine's more of a generic startup thing, in that I've found this particular thing being useful because it's been scale up. And so it means that the conversations that I've been able to have with, Chris and Alex, among others, are at a real depth, So when we're talking about pros and cons of strategic investment, when we're talking about, as Mick says, has anyone done a flip and what's your experience of it, sort of flipping the country to the US and things like that, it means that you can actually have those in-depth conversations that are beyond the bulk ecosystem thing of being a startup and here's all the original things. So I've found particularly valuable those conversations in more depth from people who've probably done this a couple of times and we're up to here. And I found that I haven't been able to have that as much during 2020 because the networks, the face-to-face networks have stopped, and often it's that serendipitous conversation that helps you there. But certainly the forums that actually help those more those founders that are further along the journey, because these are really hard problems. For example, when we were talking about strategic investments and what's the plans, and I've done it this way, and you can structure it like this or whatever, or don't touch it, or all those sorts of conversations are incredibly valuable when you're right in that situation and having those hard conversations.
That's that's very, very interesting. I've got a question. Actually, speaking of ecosystems, I've got a bit of a question for Alex, actually, because you've come out of the ecosystem that's the university ecosystem. So what's it been like coming out of that and into this world of startup and commercialization? Tell us about that journey.
So I joined the MGA team just when we were starting to commercialize the technology, and it had already gone on for about 8 years in R&D at the university before we took that leap. Which I was involved with as a third party, I guess, but not part of the core team. So I've kind of seen both sides of the coin, and I think it's definitely night and day. When you're out in the commercial world, talking with real customers, finding out people's real problems, is very different to perceiving the world through the lens of a purely academic study. So it's been a massive learning curve, but I've also been pretty blown away by the amount of support and collaboration that we've seen in the ecosystem. So it's exactly, I think, what Terry and Chris were talking about in their previous answers, where we are in an ecosystem and in a time where there are people that are incredibly keen about this and want to see solutions happen. So it may be something unique to this industry where you actually just see people saying, transparently, this is what we're trying to do. These are the problems we're having with it. How can we solve it? And it's putting it out there. Or putting out there, here's the skill set that we have. How can we help people? And it's blown me away where, as an academic, I had this kind of mindset of like the commercial world is this incredibly cutthroat environment where everyone's out there looking to just get an edge on you and cut down the competition and that sort of thing. But yeah, that's actually completely been the opposite of what I've experienced. So it's been a great journey.
And I don't know what everyone else who's listening thinks, but the fact that you said, it was 8 years beforehand that they started working on this material, that wouldn't come to a lot of people's mind. That's just how long some of these journeys take just to get started. So I think that's really interesting. So Chris, I've got another question for you. I think you talked about it a little bit before. That your product, your solution, everything's ready to go. What are the new and interesting things that you want to have capability for coming up in the future?
Yeah, so we've got a product that we've commercialized now where we can install line hardware on both conductors and on overhead earth wires, which really opens up some interesting possibilities to sensors, to dynamic line rating type activities, to having the ability to understand your network, not only you know, time at point when you take the photo, for example, but getting live data sets. Computing on the edge right now is really going to make a huge difference in how those sensors actually take that data, understand it, and then send it over what is thousands of kilometers in environments that don't traditionally have great communication systems. So for us, really looking to install smart type sensors to make grids smarter is where we'd like to go with these systems, and then moving into predictive asset maintenance and management, and really integrating with transmission network service providers. We've got the system to get the technology out there. We're there for the construction phase. We can install these components at that construction phase. It's a pretty logical progression to moving towards a more software-centric business for ourselves. So, you know, we kind of see the TX system as a bit of a Trojan horse right now. It gets out there, it gets the work done, but essentially that's where we want to move, is really into making sure the assets that we construct, you know, last the test of time and last, you know, up to 100 years, which is what we have to get out of it, right?
That's true. They are certainly long-lived assets, all of those towers. All right, now I have just noticed we have got 7 minutes left in terms of time. If anyone's got any questions they'd like to ask, please ask them now. If you'd like to come up and share your face with us, just request to share your audio and you can come and have a chat that way. That is all absolutely fine. So I'll keep an eye out for those, but I'd really like to really open it up for the panelists, just to offer their key insights of what it's like, been like over the last few months, over the last year, really. I say a few months, but it's been over the last year, and what you're looking forward to in 2021. So how about we start with that? Terry, we might start with you to kick us off in terms of what to expect in 2021 and how that might be different to 2020.
Yeah, well, it's almost a year when I was heading back from Boston, my last trip, and got in the day before mandatory quarantine came down, and it's been like that ever since. So I think, you know, certainly the last year has made us all more creative, more able to go with the flow and be flexible. But it's also meant that it has freed a lot of people from, and this is, you know, globally, from the everyday, and so they've been able to think more strategically, and so it's been a great strategic year for us because we've been able to have access to people who have bandwidth for strategic conversations. And that has honestly changed our business model a lot, that you might be going to OEM or to these things faster because we can't put ourselves in front of, you know, I think when I came back from Boston, I was training guys in the US to support our customers over there. So you can't have that sort of thing anymore. So all of our online training systems, that sort of stuff, we've become much more flexible at that, but also people are much more receptive to that sort of thing. From a remote monitoring point of view, and to echo Chris on edge computing and things like that, it's really given a leg up to all of that. So, you know, if the time wasn't now before, it certainly is now to actually really see a lot of that digitisation and rollout happen.
Very much for that, Terry. And Alex, what about you? Coming into 2021, what are the exciting things and how's that different to what you've seen in the last year?
Well, it's all been new to us from day one, so it's hard to say what's you know, what's because of the pandemic and what's just would have happened anyway. But the exciting landmark for us is bringing our pilot manufacturing online. So, you know, that's due next month, and we're seeing the first sort of commercial rollout of our bricks. So that's a real landmark that we're all super excited to see. It will be very nice to be able to see people in person again. So it's, at the moment, you know, we're based in Newcastle, and it's still sort of like, even the trip down to Sydney seems like a big excursion now. Whereas I remember kind of 2019, you know, we were visiting down in Sydney for our first capital raise almost a few times a week. So I'm looking forward to being able to meet with people in person. I think there's a lot of merit to being able to sit around a table and, you know, compare ideas person to person rather than doing everything online. But yeah, you know, it'll be interesting to see what the future brings.
Over to you.
Yeah, well, with COVID, everyone still needs energy, right? So whether that's access to heating or air conditioning, or access to information by charging their iPhones or computers. So you know, it is a great place to be playing in, regardless of the tragic, you know, events that are unfolding right now. But look, Zoom fatigue is a real thing because of COVID. But also it's opened up a lot of doors, and there's a lot of people with spare time on the internet, you know, on the global footprint, that you can go and you can request a Zoom interview, and they're kind of much more receptive to take it, and you don't have to move through their entire management pipeline to get it. So in that there's some good things that are happening as well. For us specifically, we've had to transition our training from, you know, face-to-face to a fully online environment to support our P&G customers, which was a great initiative that we had to undertake. And it's also forced us to firm up our local manufacturing pipelines. So all great kind of things that brought money back to Australia, I guess. What's happening in 2021, we want to firm up partnerships and supply agreements now that we're starting to really understand who it is we want to deal with. And I think we really want to start to target some specific global areas that really are in need of our technology, not only for the transmission construction, but just so they can get access to power. I think that's really what we're going to do.
Well, we might start to wrap it up. So thank you very much, Terry, Alex and Chris, for your time and answering all of the questions. Thank you to everyone that's been watching and asking stacks of questions. It's been really fun. I just can't believe how exciting, again, it is. The energy scene, or the cleantech scene in Australia, is an incredibly amazing place to be. So for those of you out there, if you'd like to get in contact with anyone you've spoken to today, just go to the EnergyLab website and you will be able to find all of the relevant companies' websites and get in contact. Thank you very much for everyone's time, and see you later.